Here's solutions for quiz 3 for Math 65. We're given two problems. First one's a word problem. Second one's a system of 3 linear equations. I'll like this week's perfect problem. And I solve them. So for the first one here, it's really clear. It says that make sure you use the methods we learned in class to solve this. You might be able to just look at it and kind of guess and check some numbers and figure out the answer. But that's not what I want you to do. I want you to solve the word problem by first setting it up as a system of linear equations, and then solve it using one of our methods. So let's get started. So it says that twice Xavier's age is 2 more than twice Yolanda's age. Those seem like strange names to choose. I chose them because one starts with an X and one starts with a Y. If you take this first sentence here, we can translate it. We can say twice Xavier's age could represent that as 2x. I don't know why that x is so big. 2x. Twice Xavier's age is kind of our clue for an equal sign. 2 more than, so 2 plus something. 2 more than what? Twice Yolanda's age. 2y. This first sentence translates to 2x equals 2 plus 2y. The second sentence says the sum of their ages is 7. Key here is knowing that sum means add. So the sum of their ages, if one of the ages is x and the other age is y, I know that x plus y equals 7. So what I have here is a system of 2 linear equations that I need to solve. Maybe I'll write method 1. There's 2 different ways you can do it. Well, there's 3 different ways, but I doubt anyone's going to do it the graphing method. So method 1 would be substitution. And what you do there is you solve one of these equations for one of its variables. It's up to you what you choose. I don't know, the second one is kind of jumping out at me. X plus y equals 7. I can take that x plus y equals 7, and I can subtract y from both sides to get equals 7 minus y. And then I could take that and I could substitute it into my first equation. So my first equation says 2x equals 2 plus 2y. But instead of writing 2x, I could write 2 times this thing that I just figured out x was equal to. 7 minus y is equal to 2 plus 2y. And now if I solve this equation, 2 times 7 is 14. 2 times negative y is negative 2y is equal to 2 plus 2y. I want to get all my y's together on one side of the equation and all my numbers on the other. Maybe I'll add 2y to both sides of the equation. If you do that, you get 14 equals 2 plus 4y. And now if I want to isolate these y's, I should subtract 2 from both sides to get 12 is equal to 4y. And so finally, if you divide by 4, you get that y is equal to 3. And now that you know that y is equal to 3, you jump back up here and you say, well, x was equal to 7 minus y. And I just figured out that y was equal to 3. So really, x is equal to 7 minus 3. X is equal to 4. So there's one way you could do this problem. Another option would be to use our addition method. I'll show you that just so we have them both written down here. So maybe I'll knock that off. For our addition method, we need everything to be lined up. So note in this equation, I've got my x's, my y's, my equal signs, and then my numbers. But up here, my y's are on the right-hand side of the equation. So what I'm going to do is I'm going to take this top equation in red, and I'm going to subtract 2y from both sides, and write it as 2x minus 2y is equal to 2. And the advantage in doing that is now I can take this bottom equation, x plus y equals 7, and everything's lined up nicely. It doesn't help me to add up the equations right now. If I add up the equations right now, I won't cancel out a variable. So what I'm going to do is I'm going to multiply it. Maybe I should write that different. I'm going to copy the first equation, 2x minus 2y equals 2. But then for the second equation, what I'm going to do is I'm going to multiply everything by 2. Why 2, you ask? Well, let me show you. If you multiply everything by 2, you end up with positive 2y. I already had negative 2y up here. So now when I add up these equations, I get 2x and 2x gives me 4x, and the y's cancel out. 4x equals 16. 4x equals 16, I divide by 4 and I get x is equal to 4. And now that I know what x is equal to, maybe I should put that in a box or something. I can plug that into one of my equations with x's and y's to figure out what y is equal to. I know that x plus y is equal to 7, and since x is 4, I really know that 4 plus y is equal to 7. So if you subtract 4 from both sides, you get y equals 3, which is the exact same answer we got over here. X is 4, y is 3. Two different ways to do it. You don't need to do it both ways. I just wanted to illustrate both ways because I don't know which way you're going to do it. All right, next problem. System of linear equations, but there's 3 of them. So the trick here is you want to grab 2 of these equations, cancel out one of the variables, then grab 2 different equations and cancel out that same variable. Much like on the perfect problem, you might notice that you start out, well, everything's lined up, first of all, x's, y's, z's, equals signs, numbers. But you also start out with these top 2 equations. If you add them up, the x's already cancel out. You don't have to do any multiplication or anything. So what I'm saying is I'm going to pick the top 2 equations, x plus y plus z is equal to 3, and negative x plus y plus 2z is equal to 2, and I'm going to add these guys together. X's cancel out, and I get 2y plus 3z is equal to 5. Now what I'm going to do is take any other 2 equations and figure out a way to cancel out the x's using those 2 equations. So which 2 equations should you choose? Well, you have some freedom, but I think it'll be easiest to get the x's. I have to use the third one. I haven't used that yet. Definitely have to have 2x plus 4y minus 3z is equal to negative 13. But which one should I pair with this? Well, it's up to me whether I use the first one or the second one. Since I'm going to get rid of the x's and I already have 2x here, I'm going to choose the second one because the second one has negative 1x, and it'll make it easier for me to cancel out this positive 2x if I already have a negative 1x here. I don't want to add them together right now. I instead want to take this second equation and multiply it by 2. So I'll copy the first one exactly. 2x plus 4y minus 3z equals negative 13. That's this guy. And then for this one, I'm going to multiply it by 2. So I got negative 2x plus 2y plus 4z is equal to 4, multiplying each of these terms by 2. And then note that 2x minus 2x, those will cancel out. Much like I did up here, I'll be able to get rid of the x's. These cancel out. 4y plus 2 more y gives me 6y. Negative 3z plus 4z gives me just 1z. And negative 13 plus 4 gives me negative 9. And so now what I have are two variable equations. I got 2y plus 3z equals 5, and 6y plus 1z equals negative 9. And so now that you have two variable equations, you can solve that. A couple different ways you can do it. You could use the substitution method or the addition method. Since I've been using addition, I'll continue to do that. So you want to either get rid of the y's or the z's. It's up to you. I'm going to get rid of the y's just because you got to choose one of them. To get rid of these y's, since I already have 6y down here, I'm going to want to have negative 6y up here. To end up with negative 6y up here, I'll have to multiply the top equation by negative 3. Negative 3 times 2y gives me negative 6y. Negative 3 times 3z gives me negative 9z. And negative 3 times 5 gives me negative 15. And then if I just copy this second equation exactly, 6y plus z equals negative 9, then when I add the equations, negative 6y and positive 6y will cancel out. So all I'll be left with is negative 9z plus z is negative 8z, and negative 15 plus negative 9 is negative 24. So if I divide both sides of the equation by negative 8, negative 24 divided by negative 8 is just 3. Finally figured out one of the solution to one of the variables. I know that z equals 3. I can then use that and kind of work my way back up I can say, well, I know that 6y plus z equals -9. Is that the easiest one to use? I can take this z and plug it into any equation that has z's and just one more variable in it. And it's up to me which one I choose. I don't know. Maybe, how about this one? I think this one looks a little bit easier. I'm going to take this 2y plus 3z equals 5. And I'm going to plug in z equals 3. So I'm going to say 2y plus 3 times 3 equals 5. In other words, 2y plus 9 equals 5. Or 2y equals, if I subtract 9 from both sides, -4. So finally, y is equal to -2. Now that I know z is 3 and y is -2, I can plug both those into an equation that has x's, y's, and z's in it. It's your choice. You can use any equation that has x's, y's, and z's in it. I'm going to take this one up here. This looks pretty easy. X plus y plus z is equal to 3. However, I know that y is equal to -2. So x plus -2, in other words, x minus 2, plus z, which is 3, must be equal to 3. X plus 1 is 3, so x is just equal to 2. So sort of the chain of logic is like this. And that's the end. These kind of hard, these systems of 3 linear equations, but once you get the hang of keeping everything straight, it's really just the methods we've been using. It's kind of like multiple problems in one. But I guess that's it. So I'll end the video here.